Okay, this section is going to introduce us to a special type of function called quadratic functions. And with a quadratic function, we're going to talk about, first of all, the standard form of a quadratic function. Now, a quadratic function is simply a parabola, and I'm going to show you a picture of a parabola. Now here's a picture of your most basic parabola, y equals x squared, and it's just it looks like a cup that kind of opens up. And for this particular parabola, it has a vertex down here, and the vertex is that bottom tip of it, which is 0, 0. Now if the parabola opened down instead of upward, the vertex would be the very top of it. So the vertex is just that tip or very top or very bottom part of the parabola, and that's the vertex. Now a parabola always has symmetry, so a parabola is always symmetric with about some vertical line. Well, when I say parabola, I'm talking about a quadratic function, so I'm talking about a parabola that opens up or down. So these type of parabolas will always be symmetrical about a line. In this case, the y-axis, or the line x equals 0, serves as the axis of symmetry. So a parabola, you can determine three things from the equation of a parabola. You can determine the vertex, you can determine whether it opens up or down, and you can also determine the axis of symmetry. And so we're going to talk about those three things next. So if the parabola is written in this form, f of x equals a times x minus h quantity squared plus k, or instead of f of x it could be y. Well, whatever the number is that's subtracted from x here, that's going to be h. We call that h. That's actually the x value of your vertex. And whatever is being added outside of the square here, that's k. And k, that's the y value of your vertex. And since the line, the axis of symmetry, is a vertical line, then the vertical line would actually be x equals, dang it, look at here, x equals h is the vertical line, because it's got to be the x value. So x equal h is the axis of symmetry. And so we will use that to find that h will be the axis of symmetry. Now, if a, this number here, a, right here, if this number is positive, the graph opens upward. And I just showed you a picture of one that opens upward and one that opens downward. If a is negative, then the graph opens downward. So if I were to give you the equation or function of a quadratic function in this form, you should easily be able to determine those three things. For example, in this particular example, you're subtracting 5, so 5 would be the x value of the vertex, and outside you're adding 3, so 3 would be the k value or y value of the vertex, and the axis would be x equals 5. See, I got it right here. So the axis would be x equals whatever that x value of the vertex is. And this opens upward. The reason I know it opens upward is because a is 3, and 3 is a number that's greater than 0. Whereas the second parabola, here you're adding 1, but if you think about when you add 1, it's like subtracting negative 1. Or if you prefer, just say it's the opposite sign of whatever's in here. So since this is plus 1, the x value of the vertex, or the h, is negative 1. And on the outside we have minus 5, so that's like plus a negative 5, so the k value would be negative 5. So that would be the k value. Now the axis, here's the x value, so the axis is the vertical line, x equal negative 1. And here a is negative because a is actually negative 2. So this opens downward. And I'll show you the graph of these two parabolas so you can see this. So the graph of y equals 3 times x minus 5 quantity squared here plus 3 is actually this parabola here. And notice that the vertex is the point 5,3, right? Isn't that what we said? The vertex was the point 5,3. And the axis, I went ahead and drew the axis for you here. Now the axis is not part of the graph. It's just a tool that we can use to get an idea of the symmetry. So notice that this half of the graph is symmetric to this half over here. So, and they're symmetric about this line, x equal 5, and that's what this black line is. This is the black line. This is not the y-axis. The y-axis is over here. This is the black line, x equal 5. And actually, I can do that in broken line, probably better off, so that you know it's not part of the graph. Okay? And then on the other graph, to graph it, I actually have to kind of scroll up because of where the vertex is and where the position of this is. And actually here you can see that the vertex is at negative 1, 5, and remember we said it opened down because a was negative. And so when we, let's see, what was I going to do? Oh, I was going to draw the axis for you. X equals negative 1. And there's the axis. Let me make it dotted for you. Okay, so there's the axis, x equal negative 1. There's the vertex, and of course it opens down. One way to find the vertex and axis of symmetry is by completing the square. And the reason we have to be able to do that is because many times our quadratic function, instead of written in the form that I just gave you, it might just be written in this form, where you have y equal ax squared plus bx plus c, kind of like this one here, y equals x squared minus 6x plus 3. Okay, well, what you can do is you can complete the square to get it into this form up here. Now, it's a little bit nasty, but it'll allow you, there is a way to take this form and put it into the standard form. Okay, so what we would have to do is we need to have a perfect square trinomial here. And remember, in order for us to have a perfect square trinomial, this constant has to be a certain number. And actually, if you remember, we completed the square before. We took 1/2 of the x coefficient, which is negative 6. Half of negative 6 is negative 3. Then we squared it and got 9. So we need this number to be 9. But the difference here is we're going to be doing everything on the same side of the equal sign. So what we're going to do is we're going to take x squared minus 6x and we're going to add 9 to it. So I'm going to take the x squared, the minus 6x, and I'm going to add 9 to it. But I can't just add 9 over here unless I also take it away. So I'm also going to take 9 away from this 3. So by adding 9 here and taking it away here, I keep everything equal. But when I added the 9 here, it made this now a perfect square trinomial. And I can write that as x minus 3 quantity squared, and then 3 minus 9 is minus 6. So from there, I can see that the x value of the vertex is 3. And from here, the y value of the vertex is negative 6. The axis is just this number here. It's the vertical line corresponding to that number, so it's x equal 3. And since the constant here would be understood to be 1, that's a positive number, so I know it opens up. And the other thing that I didn't tell you about quadratic functions is all quadratic functions have a domain of all real numbers. So the domain is all real numbers. Now, in order for you to understand how I got the range, I need to show you the graph. Okay, now the range is actually going to be minus 6 to infinity. I had used the x value, and that's a common mistake, but it's the y value, minus 6 to infinity. The range represents all possible sets of y values. And so let me show you this on the graph. So here's the graph of that parabola. Notice that the lowest y value is negative 6. And then, of course, if you go up, 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 you can hit every y value above that. So therefore, negative 6 is the lowest y value, and you can get every y value that's above negative 6. Okay, so now let's look at this next one. When you have a coefficient other than 1 with the squared term, you need to factor that out before you do anything. So since I have a coefficient of negative 3 with x squared, I'm going to factor negative 3 out of those three terms. And if I factor negative 3 out of this, I'm going to get x squared. If I factor negative 3 out of this, I'm going to get minus 4x. If I factor negative 3 out of this, I'm going to get plus 1. Now, let's forget about the negative 3. Just kind of hold on to it there for a while. And just focus on what's inside this parentheses here. Inside this parentheses, we have x squared minus 4x plus 1. Okay, so I want the x squared minus 4x to be a perfect square. Well, the number added to that has to be half of this, negative 4, squared. So that's how I find what number to add to make it a perfect square. So take half of negative 4 and get negative 2. Square it, you get 4. So I need to add 4 to x squared minus 4x. So I have x squared minus 4x, and I'm going to add 4. Now notice I'm keeping the negative 3 outside of all of this. Okay. Now, I still have the 1 on the inside. So remember, if I added 4 here, I've got to take away 4 here. So I take away the 4. See, really the 4's cancel each other out, but I'm using them to write it in a particular form. Now, x squared minus 4x plus 4 is now can be written as x minus 2 quantity squared. 1 minus 4 is just negative 3. Now remember, I have this negative 3 sitting outside of this parentheses here. And so I need to distribute that back through. Now you can't multiply the negative 3 into the square, but you can write it as negative 3 times the square. And you can multiply negative 3 times negative 3 and get plus 9. And now we have it in the standard form. And from that standard form, I can look at it and see that the vertex, the x value of the vertex is 2, the y value of the vertex is 9, the axis is x equal 2. Since a is negative, negative 3, it must open down, and of course the domain, again, it's always all real numbers for a quadratic function. And now I'll show you how I know what the range is. You don't have to look at the graph to figure out the range, but I think it's helpful in order to explain it. So see, for this graph, the vertex is 2, 9, so the largest y value is 9, and there's no values above 9, only values below 9. So since when we're identifying the domain or range, we always start with the smallest value and go to the largest. Well, this parabola goes down infinitely, so the lowest y value we would say would be negative infinity. So it goes from negative infinity up to and including 9. And so that's how I know that the range is negative infinity to 9. And that pretty much is all I can do on this video. In the next video, I'm going to share with you a vertex formula that will allow you to avoid completing the square. And I know that'll make you happy.